Hello, hello! Here is the video going over the 3.1 to 3.4 quiz review. So this video focuses on finding slope, graphing lines, as well as writing equations for lines. So the first thing we're going to do is determine the slope, and we have three different scenarios. We have the graph, we have a table, and we have 2 points. Now each one of those scenarios is going to require something slightly different, but it's all the same idea. And what that idea is we'll go to the graph, and it is your rise over your run. So if I look at my graph, to get from one point to the next, what I need to do is I need to go up and then to the right. So when I'm looking at the graph, my slope m is going to be equal to the rise over the run. And your rise is how you are moving up and down. The run is how you are moving to the left or to the right. So to get from my first point to my second point, I went up 1, 2, 3, 4, and to the right 1. So it'll be 4 over 1, which of course we can just write as 4. Similarly, rise over run is also related to your table in terms of change in y over the change in x. So rise is how you're moving up and down, and that's what's happening to our y's. So when I look at my table, that's my change in y over my change in x, which is literally the same thing as rise over run. So if I look at my table, I want to see what is happening to my y's. So if I look at my y values, each time it is decreasing by 1. So I'm going to write -1 on my y side, and then I'm also going to look at my x values because I want to see what the change in x is. Well, for my x's, I am adding 3 each time. So change in y is -1 over my change in x, which is 3. So my slope for that is -1/3. When you have 2 points and you want to find the slope, you're going to use the formula for calculating slope. So that is y2 minus y1 over x2 minus x1. And what that formula actually means is I'm finding the change in y over the change in x. So the difference in my y's over the difference in my x's. So it's all related, whether you have a graph, a table, or 2 points. So I'm going to start by labeling my points x1 and y1, x2 and y2, and I can plug it into my formula. So y2 is 7 minus y1 over x2 minus x1. Now right here I am subtracting a negative value, so that is the same thing as adding. So I have 7 minus 5 over 6 plus 4. So 7 minus 5 is 2 over 10, which reduces to 1/5. Okay. Now, it tells us to rank our slopes from problems 1 to 3 in order of steepness, from the least steep to the greatest. So, whichever one has the lowest steepness to the highest steepness. Now, in terms of steepness, what you are looking for is you are looking for the lowest number to the highest number. And you are not paying attention to whether it is positive or negative, because your positive slope will just tell you that your line is moving up to the right. Your negative slope is going to tell you that your line is going down. So when we're talking about steepness, we're just looking at the numbers itself and not necessarily whether it's positive or negative. Now, in order to compare all of these numbers, I'm going to change my fractions to decimals so it's easier to compare. So 1/3 is 0.33, whoops, and 1/5 is 0.2. And what I'm going to do is I'm going to write my order of steepness from least to greatest. So my lowest was 1/5. Next was the -1/3. And finally, the steepest is 4. So that right there is your slope in order of steepness. Now, number 4, if you look at your table, you got something crazy going on with your x's. All of your x's are just the value 3. So if I look at my change in x's, there is no change in x's. That's a 0. If I look at my change in y's, since I'm dealing with a table, I am subtracting 2 every time. So when I write my slope, it's change in y over my change in x. And if I look at what I have a 0 underneath. Now, anytime you have a 0 underneath, that slope is going to be undefined. So I want you to remember 0 underneath is undefined. All right, number 5. I have 2 points again, so I'm going to use my slope formula. x1, y1, x2, y2. I have y2 minus y1 over x2 minus x1. Once again, subtracting a negative, which changes that to a plus. So I have 9 minus 9 over 2 plus 7. So 9 minus 9 is 0 over 2 plus 7, which is 9. And 0 divided by 9 is going to give you 0. So my slope for that is 0. Okay. Next up, writing equations. So it says write a linear function in any form given the table, 2 points, or a graph. So I have 2 forms to choose from. I have point-slope form, which is this right here, and slope-intercept form. So it says you can use any form. There is a method to which form you should use depending on the information that's given to you. But regardless of the form that you choose, the very first thing you should always find is the slope. Because if you look at both of these formulas, they both have that m in there, and m represents your slope. So I'm going to start by finding my slope first. So I have my table. I'm going to find my change in y's over my change in x's. So let's see what's happening to my y's. I'm going from 17 to 15 to 13, etc. So I'm subtracting 2 each time. For my x's, -5 to -4 to -3, I am adding 1 each time. So if I look at my slope, rise over run, -2 over 1, which is just -2. Okay. Now, for point-slope form, that x1 and the y1 represent any point that is on the line. So really, for this table, I could have 1, 2, 3, 4, 5 equations as my answers. Of course, you only need to write down 1, but I'm going to show you all 5, just so you can see every single possibility for your answer. So I'm going to start with my first point, which is -5, 7. -5, 17. I'm going to do y minus the y equals m, which I know is -2, because we found that slope, x minus my x value. So I'm subtracting a -5, which means I'm going to change that to a plus. So there is possibility number 1 for your equation. Number 2, I'm going to use the second point. So y minus my y equals m times x minus my x. But once again, subtracting a negative, so I'm going to change that to a plus. Third point, y minus 13 equals -2, x minus -3, y minus 11 equals -2, x minus -2, and finally, y minus 9 equals -2, x minus -1. Now, if you'll notice, for this particular table, I only used point-slope form. I did not even bother touching slope-intercept form, and the reason why that is because for slope-intercept form, you absolutely need to have your y-intercept. I'm going to make a little note over here. Your y-intercept is the point 0 and then b, some number. If I look at my table for number 6, I did not have any value where my x was 0, so I did not have my y-intercept listed in the table. Now there is a way to get this into slope-intercept form from point-slope form, but I am not going to discuss that right now. I'm sticking with just the point-slope form for this one since my y-intercept was not given to me. Okay, number 7. I'm going to use the same idea. I'm going to start by finding my slope. So change in y, I am adding 2 each time. Change in x, I am adding 3. So my slope, m, is going to be change in y over change in x, so 2/3. Once again, you could have point-slope form for every single one of those points. Or with this particular problem, you could actually do slope-intercept because if I look right here, I have the y-intercept. My y-intercept is at 0, 4, and that 4 actually represents your b. So if I wanted to write this in slope-intercept form, I have y equals 2/3 x, I'm following y equals mx plus b, and then plus 4. So there's your equation in slope-intercept form. If you want to see all the equations in point-slope form, I'm going to do y minus my y. This is my first point. 2/3 x minus -3. I'm going to do y minus 4 equals 2/3 x minus 0. Y minus 6 equals 2/3 x minus 3. And again, I'm just going through every single point on my table to show you all of the possible answers. My next point is 6, 8. So I have y minus 8 equals 2/3 x minus 6. And then finally, y minus 10 equals 2/3 x minus 9. So for number 7, we have 6 different possibilities. And that was because it gave us the y-intercept, so we were able to write it in slope-intercept form. Okay, number 8, I have my 2 points, so I'm going to start by finding my slope using, the slope formula. So I have m equals y2 minus y1 over x2 minus x1. So I am subtracting a negative right here, so that is the same thing as adding. So 1 plus 5 is 6. 2 minus 0 is 2. So my slope for this scenario is 3. Now if I look at my points, I do have the y-intercept because that is when my x-coordinate is 0. So this -5 actually represents the b. So if I wanted to write the equation in slope-intercept form, y equals mx plus b, I could do y equals 3x minus 5. So there's our slope-intercept form. I could also do point-slope with either of these points. So y minus -5 equals m, x minus 0, y minus 1 equals m, x minus 2. So again, I am just following these two formulas that we had at the top over here. I am replacing my m and my x1 and my y1, which represent any point on your line or any point that's given to you. Okay, and number 9, same thing. I'm going to start by finding my slope. X1, y1, x2, y2, so I have -1 minus 4 over 7 minus -3. Subtracting that negative again, so -1 minus 4 is -5, 7 plus 3 is 10, and of course always reduce your fractions if you can, so that reduces to -1/2. Now, if I look at either of these points, neither of them had 0 as the x-coordinate, so I do not have any y-intercepts given to me. So that means I cannot use slope-intercept form. Instead, I can use point-slope form using either of these points. So I have y minus my y, I'm using the first point, this one right here, equals m x minus -3 becomes x plus 3. Now, using my second point, I'm going to do y minus -1 becomes y plus 1 equals -1/2 x. Oh shoot, did I do something wrong? Wait, no. Sorry. I thought I was looking at the wrong numbers. I have y plus 1 equals -1/2 x minus 7. And those are your two possibilities for number 9. Okay. Number 10. So I have a graph, so the first thing I want to do is I want to find the slope given the graph. Now when you're given a graph, you want to do rise over run. So that is how you're going from one point to the next. So first I went down 1, 2, 3, 4, 5, and then to the right 1, 2, 3. So I have my rise, which is -5, over my run, which is +3. Now these 2 points, that ordered pair is 0, 6, and this point right here is 3, 1. And I'm going to use those 2 points to be able to write my equation. Now this particular point up here is the y-intercept, and I can see that is where it crosses my y-axis. So I can use slope-intercept form since I have my b, which is 6. So I have y equals mx plus b, so -5/3 x plus 6. If I wanted to use point-slope form, I could do y minus 6 equals -5/3 x minus 0, or y minus 1 equals -5/3 x minus 3. And that was just using the 2 points that were given to me on our line. Okay, number 11. So I look at the points that are in nice spots where I can easily figure out those ordered pairs. -4, 0 was already given to us. The second point is at -1, 2. And I'm going to figure out my rise over my run to get my slope. So I'm going up 2 and to the right 3. So my m is a +2/3. Now, if I look at these 2 points, neither of those points are the y-intercept. Your y-intercept is actually right here. And on the graph, I can see that it's in between some boxes. So I don't know exactly where that point is, so I'm not going to use my y-intercept to write the equation. Instead, I'm going to use point-slope form since I have 2 other points, and I can use that to write my equation. So starting with this point, first I'm going to do y minus my y-coordinate equals m times x minus my x-coordinate. And that became a plus because my 4 was negative. With my other point up here, -1, 2, I'm going to do y minus my y-coordinate equals m times x minus my x-coordinate. So there are your 2 possibilities in point-slope form for that particular line. Whew, writing equations is a lot, especially when I show you every single possibility that you can have. Okay, shifting gears, moving on to graphing. So in order to graph, you do need to understand which form you actually have. So if I look at number 12, it is in the y equals mx plus b form. So that means I can identify my slope, which is the number in front of x. So in this case is -3. And my b is what we're adding and subtracting, so that is 7. Now, I always want you to write your y-intercepts as a point. So my y-intercept for this is 0, 7. And that is how you are going to start your graphing. You're always going to begin at your b. So I'm going to start by plotting 0, 7. So there's my first point. And then I'm going to use my m to move. Okay, so my slope is -3. I can write that as -3 over 1. So that means from my B, I'm going to go down 3 to the right 1. Down 3 to the right 1. And it does say to plot at least 2 points. I'm actually going to fill my entire graph. I'm going to keep going down 3 to the right 1 so you can see how all of these points would end up on the graph if you continued. And I can go in the opposite direction as well from that purple point and go up 3 to the left 1. And now I can connect all of these dots and make a straight line. So the more dots you plot, the straighter your line's going to be, but you should always use a straight edge. That way your lines look really nice. Okay, 13, once again, is in slope-intercept form. So my n is the number in front of x, so 3/2, and my b is what we are adding or subtracting, which in this case is -8. So that means my y-intercept is at 0, -8, and that is where I'm going to begin, because I always begin at my b. And then I use my m to move. So my slope is 3/2, so I'm going to go up 3 to the right 2, up 3 to the right 2, and so forth. I'm going to keep going because I like to fill up my entire graph. Up 3 to the right 2, just for the sake of accuracy. And I can go ahead and connect all of these dots to draw a straight line. So there is your graph for 13. Okay, number 14. So 14 is not in slope-intercept form, it is in point-slope form. So in order to graph in point-slope form, I need to start by identifying my slope, which is still the number in front of x. In this scenario, it's a number in front of your parentheses, so -1/5. And my point, I'm going to pull out from the equation. Now, when you're pulling it out from the equation, you always want to take the opposite. So instead of having a +6, I'm going to change that to a -6. And instead of having a -4, I'm going to change that to a +4. And if we go back to when we wrote our equations, for example, this point right here, 0, 6, when it ended up in point-slope form, it was -0 and -6. So it's always the opposite. Okay, so I'm going to start by plotting my point, -6, 4. -6, 4. There it is. And my slope is -1/5, so I'm going to use that to move. So I'm going to go down 1 over 5. 1, 2, 3, 4, 5. Down 1 over 5. 1, 2, 3, 4, 5. And I think I can fit one more on here. 1, 2, 3, 4, 5. There we go. And then connect to make a straight line. Well, that one wasn't that great, so let me try again. This one looks better. Okay. All right, number 15. What the heck is 15? Okay, so 15 is just x and a number. So when I have x and a number, what I'm going to do first is I'm going to start by going to that number on my x-axis, since it says x equals 4. So on my x-axis, I'm going to go to 4, and I'm going to plot a point. Now, you always need a couple points to be able to draw a line. So I need to find another point where my x-coordinate is also 4. Well, any point that's above this point or below this point, all of these points are going to have an x-coordinate of 4. So when I connect these dots, what I end up having is a vertical line. So when I have x equals a number, I'm going to make a little note. That ends up being a vertical line. And a friendly reminder, vertical lines have an undefined slope. Okay, so x equals a number. That is going to be a vertical line with an undefined slope. Number 16, this sucker is in standard form. So for standard form, we start by graphing our x and y intercepts. Now for my x-intercept, what I'm going to do is I'm going to plug in 0 for y. So my x-intercept is when y equals 0, and my y-intercept is when x equals 0. So I'm going to set up two equations. So for my first one, I have 3x plus 6 times 0 equals 12. And I'm going to use that to solve for x. Well, 6 times 0 is just 0. So I don't really need to be adding anything right there. So I have 3x equals 12. So that means x equals 4. Okay, so that means my x-intercept, when I write it as a point, my x-coordinate is 4, y-coordinate is 0. Draw a line to separate my thought process. For my y-intercept, I'm going to plug in 0 for x. So I have 3 times 0 plus 6y equals 12. Well, 3 times 0 is just 0. So I have 6y equals 12. So y equals 2. So when I write that as an ordered pair, my x-coordinate was 0 because I plugged in 0 for x. Y-coordinate is 2. You always need at least 2 points to draw a line, which I have. I have my x-intercept at 4, which is right here. Y-intercept at 2. And I got my 2 points, so I can go ahead and draw a straight line. Now, whenever you're graphing and you have your points, your lines should go all the way across your graph. You don't really want to see these itty bitty lines right here that just connect your 2 points. I want to see graphs or your lines going all the way across the graph. Okay, so we did have this scenario when we had x equals a number. Now let's look at it when we have y equals a number. Same idea, since it's y equals, I'm going to go to my y-axis, and I'm going to plot a point at -6. Now I need to find other points where my y-coordinate is -6. Well, those will be any point that's to the right or to the left. And that creates a horizontal line. Okay. So y equals a number, I'm going to make a note. That is a horizontal line. Can't spell horizontal. Oh, I was spelling it right. Horizontal. Okay. No, it looks weird. Horizontal line. And for horizontal lines, you have a 0 slope. Okay. Almost done. Number 18 says to label each of the equations above as either point-slope form, slope-intercept form, or standard form. So let me go back to the beginning of the graphing so I can label each one. So number 12, we did talk about this as I was explaining the problems, but number 12 is slope-intercept because it was in the form y equals mx plus b. 13 was also slope-intercept. Y equals mx plus b. 14 was point slope. When I just have x and a number, that's actually in standard form. So what it could look like in full standard form is you would have just x plus 0y equals 4. Number 16 was also in standard form. And 17, you actually have 2 options. This could be slope-intercept, because we could write it like y equals 0x minus 6, so that minus 6 represents your b, or you could label it as standard form. And then for standard form, you would have 0x plus y equals -6. Okay, which one of these points is a y-intercept? Circle 1. So your y-intercept always needs to have x being 0. So so that is going to be 0, 4. So how do I know? I know because the x-coordinate is 0. All right, so that concludes the video going over your quiz review. Good luck on your quiz.